Hello, I'm WP Suazo, and I want to talk to you about the production possibility curve in efficiency. The numbers up here along the top of the board represent a styrofoam factory that can make styrofoam bicycle helmets and styrofoam coolers. Um, all of these points listed here represent goals that are efficient. Goals that where both numbers fall in between these numbers listed are also efficient. Efficiency is one of the most interesting things to define in a class of economics. But for our purposes here, something that is efficient is a pair occupying either the same gap or point. So 48 and 8 is an efficient goal, but so wouldn't 50 and 5 because both 50 and 5 fall in the same gap. All right, let's consider some pairs. The first one we'll consider is 16 and 16. So here's coolers, here's helmets. What about 16 of both? Well, if we have 16 and 16, we can only make 16 helmets with no coolers. So 16 and 16 is something that is not efficient, but it's not inefficient, it is outside efficiency. Because to take this proposed goal and make it fit in here, we have to reduce, we have to take away from this proposed goal. So this is outside or beyond what we can do. If we consider 15 of both, and 15 both fall in this gap. 15 helmets is between 12 and 16. 15 coolers is between 28 and 0. So this 15 and 15 is efficient because both of these numbers occupy the same gap. All right, well, let's consider 12 and 12. Well, I see 12 helmets right here. 12 helmets, 12 helmets. When we make 12 helmets, we're expected to make 28 coolers, not 12. So if we are inadequate or inefficient, we describe it as such. Inefficient. We know we are inefficient when something's missing. When we have 12 helmets, when we make 12 helmets, we should have 28 coolers, not only 12 coolers. Okay, we keep on going with the examples. How about, say, 48 and 8? Well, let's take a look. 48 and 8. Oh, there it is listed right here at point C. So if it's listed, occupying the same point, it is efficient. We also consider 43 and 13. Okay. Is it efficient? Because we gave up 5 coolers and we gained 5 helmets. 1-for-1 trade-off, is that something that's possible? Well, that might be possible between A and B, but if we look at the numbers here, we don't seem to be up in that realm. Okay, 43 coolers is right here. 13 helmets, does 13 helmets fit between 8 and 12? No, it does not. So this goal, this proposal is too ambitious. We have to reduce it. If it's too ambitious, if it's too big, then we are outside of what is possible. All right, let us consider 50 and 5. 50 and 5. Well, 50 coolers, here are 60 coolers right here, so 50 would be between B and C. Does 5 fit between B and C? Yes, it does. So if a pair occupies the same gap or point, it is efficient. Now, these numbers along the top of the board is a schedule. It would be better or more efficient, I should say, if we had a mathematical expression, plug in one of these values, and this expression would tell us how much of the other is possible. But we don't have mathematical expression here, we just have a simple schedule. So let's consider this. As we go from 50 coolers and 5 helmets to 55 coolers and 7 helmets, since we're having more in both categories, that's economic growth. When we went from 43 and 13 to 50 and 5, we gave up coolers to have more helmets. That's economics in any static situation, having one of more by giving up something. But this one here represents economic growth. Is it possible though? 55, well, 55 falls between B and C, as there's 7 helmets between B and C. So this one would also be efficient. But if we had a better definition of efficiency through a mathematical expression, through an equation, then we wouldn't have this happening. But that's nothing to be concerned about if your teacher is teaching you this concept by using a schedule like that. Okay, let us consider 62 and 6. 62 coolers and 6 helmets. Taking a look here, 62, 62. 62 coolers is AB. Is 6 helmets in the interval AB? No, it's not. It's someplace else. To get 62 coolers, we have to have 1, 2, or 3 helmets, so this is too much. Or we could say, well, 6 helmets, we are able to have 6 helmets if we're willing to settle for 50-something coolers, not 62. So this one is outside our capability. What else do we consider next? How about 25 and 10? 25 and 10. 25 coolers. Well, 25 coolers is DE. Does 10 fit in between 12 and 16 helmets? No, it does not. So this one, to become efficient, would need units added to it. So right now it is insufficient or inefficient. All right. If efficiency is our goal, let me write that for the last 2 examples. But I will only give you one number. Let's see what we come up with. So the first proposal has 30 coolers. So if we're to make coolers, but 30 of them, and a complement of helmets that would keep us efficient, how many helmets could we expect with 30 coolers? Well, let's find 30 coolers. 30 coolers is right here between C and D. So if we make 30 coolers, we're also expected to make between 9 and 11 helmets. So I'll put 9 through 11. Anything on the heavy end would constitute a goal that's outside. Anything short of the lower end, which is 9, would constitute a goal that's inefficient. All right, how about making 3 helmets and a complement of coolers that keeps us efficient? Let's take a look. All right, 3 helmets. 3 helmets falls between A and B. So we would be efficient so long as we make between 63 and 61 coolers. As a parting note, I say you're given a pair. If a pair occupies a point, you know it's efficient. If a pair occupies the same gap, such as 30 and 10, that's also efficient. But if you're given a proposal where the pairs are stretched, say 55 and 10, 55 and 10, you ask yourself, what do I have to do to take that proposal and make it efficient? If you must reduce it, 55 and 10, 55 coolers and 10 helmets is too ambitious. If we have to reduce it, it is outside. Conversely, if we're offered a goal where we make, again, 50 coolers, but this time only 2 helmets, that one's too meek. That one's too small. To make it efficient, either we have to make more helmets or more coolers. So if you have to add to a pair, then there you know that it's inefficient. I hope this has shed some light on this topic. Please look for my other videos. Thank you.